In part 9.1, I talked about the importance of choosing an effective performance metric. We now start to look at a few of these in more detail, and we start with the standard implementation of the profit factor. Now, as I'm sure you're already aware, you calculate the profit factor by taking the sum of the profits from all of the profitable trades and then dividing that by the sum of the losses from the losing trades. Now, as I said before, we need to consider both upside reward and downside risk as part of our implementation of any performance metric. And so the way that profit factor does this is because clearly the profits relate to the reward aspect and the losses relate to the risk aspect. Now, profit factor does have a fairly serious downside to it, and that relates around a bias introduced by the position sizing and how that changes throughout the course of a backtest. So let me show you what I mean. Now, it's always a good idea in any trading system to scale your position sizing of your trades with the equity that's in the account. And when you do that, what typically tends to happen to the equity curve in a backtest is that it grows in an exponential way. And that's fine, but let's now take a look at what the impact is of this on our profit factor calculation. So the trades that occurred towards the end of the backtest have a much larger position size, and therefore both the profits and the losses of these trades are going to be much bigger than the losses and the profits of the trades early on in the backtest. And what this means is that it introduces a bias where the majority of the numbers that are playing a part in the profit factor calculation are coming from this latter end of the backtest cycle. And these ones towards the beginning have a much smaller influence on the calculation. Now, if you were to have losing parameters that come down like this, then it's exactly the opposite that's the case now. So with these trades here don't play a very big part in the calculation of profit factor for these parameter values because the equity is low, and so therefore the position size is low as well. And most of their contributing numbers come from this early cycle, so it's the opposite. And so this is introducing a major bias in the selection process, whereby we're not comparing like for like across different parameters. So let's just look at one more example here with a slightly more complex equity curve. So here the system initially performs very well early on in the backtest, but then the performance degrades and the system ends up losing money. As we've said before, the majority of the influence in the profit factor score is coming from those values that have high position sizing. So this period here when the performance was doing well. And then these down here where the system is losing money don't have as big an influence, and so this may well appear better in terms of profit factor than it deserves. But the good news is that we can get over this issue and remove the bias relatively easily by normalizing the contributing values. So click here to go to part 9.3 to see how this is done.